Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, welcome to the TV learning program. This is teacher Pascal, and today I will be with Senior 5 students learning chemistry. In the previous lessons, you studied alcohols, the nomenclature of alcohols, and the physical properties of alcohols. Today we will go on with the same unit, but we will change the lesson, and today's lesson will be the preparation methods of alcohols. Something which is very interesting with organic chemistry is that as you go on to the next and next unit, you find that what you are about to study, you have already covered it in another unit. For example, the preparation methods we are going to discuss today, you have seen some of them in other units, previous units, as chemical properties of those other organic compounds. But before we go deeper in today's lesson, I want you to try an exercise for revision. Here we have our revision exercise, and I want you to name those two compounds. We have CH3COH, CH3 and CH3, and the second molecule is CH3CHOH, CH2CH3. Question number 2, you will suggest how you can transform this alkene into this alcohol. There is no change in the number of carbon atoms in the chain. You have 1 minute to try the exercise. What is the name of this compound? We have a chain, and the main chain here has 3 carbon atoms. We have 3 carbon atoms, and we have a branch. And then, because of having a chain with 3 carbon atoms, we will call the name for the parent chain is prop. And then it is propane 1 all. Sorry, here it is on the second carbon, so it will be propane 2 all. And we have a branch which is also on the second carbon, so it will be 2-methyl propane 2 all. And the second compound is this one. We have no branch. And our parent chain, this one, has 4 carbon atoms with the OH group on the second carbon, and then the compound will be called butane 2 all. Secondly, how can we convert this alkene into an alcohol? I hope you remember how alkenes react with water to produce alcohols. What is the main condition to carry out that conversion? When you are transforming an alkene into an alcohol, you add water, and the reaction must be done in acidic medium. We do it like this. We have CH3CH, CH2, the alkene, plus H2O, and the reaction is done in acidic medium, concentrated sulfuric acid, and we produce CH3CH, CH3. This will be the major product. Hope you remember Markovnikov rule. You remember Markovnikov rule, so this will be the main product. So this is how we can transform our alkene into this alcohol. And starting from here, you can see that If we are about to prepare alcohols, this is one of the methods we can use to get alcohols from other compounds. Starting from alkenes, and you make them react with water. So one and the first preparation method of alcohols is to start from alkenes. Starting from alkenes, alkenes react with water in acidic medium to produce alcohols. We have the example here. The second question, we have the example. An alkene reacting with water in acidic medium to produce an alcohol. What other reactions do you remember that can be used to prepare alcohols, to produce alcohols? You have also studied alkyl halides, halogen alkanes. Which reaction of halogen alkanes do you remember that can be used to produce an alcohol? There is, and that reaction is when we start from alkyl halides halogenoalkanes can react with sodium hydroxide, potassium hydroxide, or silver hydroxide to produce alcohols. Here we have to be very careful with the working conditions, because when you change the working conditions, you may get a product which is totally different from what you wanted to produce. So the working conditions, if you want to start from an alkyl halide and prepare an alcohol, you have to be very careful with the working conditions, and those working conditions are these ones. The reactant, the sodium hydroxide or potassium hydroxide, must be dilute, aqueous, in aqueous, and then you make a dilute solution. And you also need to reflux. You need some heat. You need some heat, but refluxing means what? It means that as you are heating your mixture, you use a vertical condenser so that you avoid the escape of some molecules from your reacting mixture. So a refluxing column is a vertical condenser which will condense the vapors which may come up from the reacting mixture so that they may be cooled down and go back in the reacting mixture without escaping from your reaction vessel. Examples we have, generally, if it is CH3, and here we have X representing the halogen, if you add sodium hydroxide, aqueous, and you reflux, what you produce is RCH3OH plus sodium X, sodium halide, and water. And the example we can use CH3CH chloride, CH3 plus sodium hydroxide, and we reflux to produce propane 2-ol plus sodium chloride and H2O, water, molecule of water. Another method we can use to prepare the same alcohols is the preparation from carbonyl compounds. Preparation from carbonyl compounds. You have talked about the carbonyl compounds when you were listing the different homologous series you will be dealing with in Senior 5, Organic Chemistry Senior 5. And the carbonyl compounds have two main classes, and those two main classes are ketones and aldehydes. So you can start from a ketone or an aldehyde and prepare alcohols. How can we do that? We can do that by reducing them. Reduction of carbonyl compounds. Reduction of carbonyl compounds. So when you reduce a carbonyl compound, you produce an alcohol. Specifically, when you reduce a ketone, which has this general structure, R representing an alkyl group, you remember that, and this is the carbonyl group. When you reduce, let us add hydrogen in the presence of Nico catalyst. The catalysts that can be used here are Nico, platinum, palladium. We can use all those catalysts. We can also use other reducing agents like lithium aluminum hydride dissolved in ether. And what do we produce? We produce an alcohol with the general form, this one. What kind of alcohol is this? This is a secondary alcohol. And if you use an aldehyde with this general form, what do we produce? Let us use another reducing agent here, lithium aluminum hydride in ether, and we produce RCH2OH. And this is a primary alcohol, while this one is secondary alcohol. So when we reduce ketones, we produce secondary alcohols, but when we reduce aldehydes, we produce primary alcohols. There is no way of reducing a given compound or a given carbonyl compound and produce a tertiary alcohol. That is not possible. So when we start from carbonyl compounds, we can only produce primary alcohols from aldehydes and secondary alcohols from ketones. Now let us have some examples. CH3CH3O, this is a keton. When we add hydrogen in the presence of Nico as a catalyst, what do we produce? We produce CH3CHOH, CH3. Propane 2-ol, a secondary alcohol, and when you start with an aldehyde, ethanol, what do we produce? We produce a primary alcohol. What alcohol are we going to produce from ethanol? Think about it. Ethanol, good. It's ethanol, CH3CH2OH. The next method of preparing alcohols is to start from an ester. You can start from an ester. What is an ester? Esters are functional group isomers of carboxylic acids. You have seen that. If we start from an ester, we have a reduction of esters which can give us alcohols. So we have RCOOR, which can be reduced to give us RCH2OH plus ROH. Example, CH3CO or CH3 plus hydrogen in the presence of nickel as a catalyst, we produce 2 moles of CH3, CH2OH. So if you have, we don't produce 2 similar molecules because the alcohol, the ester we have is not symmetrical, so we produce CH3CH2OH plus CH3OH, 2 different alcohols because the parts we have here are different. This one is composed by 2 carbon atoms, but this one is composed by 1 carbon atom, so we produce 2 different alcohols. But if you have both parts composed by the same number of carbon atoms or with the same structure, then you produce 2 moles of the same compound. CH3CO or CH2CH3 is a good example. Plus hydrogen and nickel as a catalyst. Here we produce CH3CH2OH, but then 2 moles from 1 mole of the ester. The reducing agents you can use here are the same as what you can use when reducing carbonyl compounds. We can also prepare alcohols when we use Grignard reagents. What is a Grignard reagent? It is an organometallic compound. So it is an organic compound which contains a metal. When we start from Grignard reagents, the Grignard reagents are these ones, RMGX, R standing for an alkyl group. We can produce alcohols. Grignard reagents can react with carbonyl compounds. So we have RCOH when it reacts with RMGX. This Mg is magnesium, and this X stands for a halogen. Then we put the intermediate compound in water. What do we produce? We produce RCOH and R plus XMGOH. And an example, if we have CH3COH plus CH3MgCl in the presence of water, what do we produce? We produce CH3COH, and here we have CH3. To make it clear, let me use another color. The CH3 we have here is the one which comes here. And this part is from this compound. And then we get a byproduct, which is ClMgOH. What class of alcohol is this? This is a secondary alcohol. So when we use Grignard reagents and aldehydes, we produce secondary alcohols. We can produce a primary alcohol only when we use methanol. Only when we use methanol. What happens when we use methanol? From methanol, we have H, COH plus, let's say, CH3, CH2, MgCl. In water, in this case, we produce CH3, CH2, CH, H, and OH. This part is from methanol, and this one is from the organometallic we have here, the Grignard reagent. And the byproduct we have here is ClMgOH. So you can see that what we have here is a primary alcohol. You can only produce primary alcohols from Grignard reagents when you use methanol. And when we use a ketone, like RCO, plus MgCl in the presence of water, what we produce will be RCOH with the R prime and R second, and then we produce ClMgOH. The example, let us use CH3COCH3 plus CH3 magnesium chloride in the presence of water. And what do we produce? We produce CH3COH, CH3 and CH3, as we have done for other compounds, other examples. The CH3 and CH3 have here, these three, they are these ones, this part actually, it's this one. And then the CH3 have from the Grignard reagent is here. And then the other product is ClMgOH. So as we said, you can see that when we use a ketone, we can only produce tertiary alcohols. So if you want to produce a tertiary alcohol, don't forget to use a Grignard reagent and a ketone. And the other method is to prepare alcohols from amines. Preparation from amines, and that is number 5, from amines. Primary amines, that is RNH2, react with a mixture of sodium nitrite and hydrochloric acid to produce a primary alcohol, nitrogen, and H2O along with sodium chloride. And here we have the alcohol we want to produce. If you don't want to use sodium nitrate and HCl mixture, you can use what? You can use nitrous acid. But because of being not very stable, we use this mixture. And the example, we have CH3NH2 plus reacting with sodium nitrite and HCl to produce CH3OH plus N2 H2O and sodium chloride. That is how we can prepare alcohols. And here there is how we can prepare ethanol. Ethanol can be prepared by using all these methods. We have seen some of them, of course, because it is a primary alcohol, but there are other methods we can use. You know how we make, for example, here in Rwanda, the traditional beer, the one we commonly call urwagwa. So if you want to make that, you use alcoholic fermentation. And here is a chart showing how we carry out alcoholic fermentation. You can start with starch. When they use maize, they use sorghum, then those substances, those cereals, they contain starch. So from starch, with this molecular formula, you use diastase, this is an enzyme in the presence of water, to produce a sugar which is called maltose. And from maltose, an enzyme which is called maltase in the presence of water will convert this maltose into glucose. You know the molecular formula of glucose. And zymase will help in the conversion of glucose into ethanol. This is the molecular formula of ethanol. That is the process of alcoholic fermentation from starch. At this point, we use yeast. You know yeast. Those people who are doing biology, you know yeast. So yeast is added to provide those enzymes which are helping in the conversion of these substances. It is also possible to start from sucrose, where sucrase will convert the sucrose into glucose, but the only difference here is that from maltose we produce glucose, and those will be two molecules, but from sucrose we produce glucose and fructose, and then we convert by the use of zymase into ethanol. So this is a flow chart of how you can prepare ethanol from starch, from sucrose, from sugars by using alcoholic fermentation. And if you want, you can carry out this at home. We have sugar, you can get some yeast, so you can carry out the alcoholic fermentation. When you will set up the containers to be used, don't forget to put there some space where the coming out carbon dioxide can escape from, because as its concentration increases, then it will reduce the lifespan of the yeast cells. Here we have a homework, and you will try it when you will get time. Don't forget to try it. Complete the equations below. We have an alkyl halide reacting with sodium hydroxide, and the reflux, what will be produced? This alkene, when it reacts with water, what will be produced when the reaction is carried out in acidic medium? Aldehyde reacting with hydrogen in the presence of nickel, and this ketone reacting with lithium aluminum hydride in the presence of ether. We also have an ester undergoing a reduction. And the exercise, which is a bit more powerful, how can you prepare butane 1-ol from ethyl chloride and prepare propane 2-ol from this aldehyde? What reagents and conditions are used to convert a halogen into an alcohol? Let me hope that you will all do the exercise, the homework, very well. Thank you for your time. Thank you for your attention. I hope to see you next time, safe and sound, for the next lesson. Stay safe.